Picking up from where we left off in part one, this is part two, trial number three. Let's hope this works. So we talked about blue color being cyanosis. It could be low oxygen blood, which lowly oxygenated blood is a maroon burgundy color. And when that is seen through the collagen fibers in your dense connective tissue, it appears blue, but really the blood is the same color as it is when it comes out in the vacutainer when they draw your blood. It's that dark burgundy red. Oxygenated blood is bright red, so it doesn't look as bright as bluish underneath the skin. So veins and other pigments deep in the arm appear blue. Like I say, the collagen diffracts the light, much like the sky diffracts the light. Our sky, again, is blue because the water molecules diffract sun's light. The moon, its sky is black because it doesn't have an atmosphere, no diffraction of the sunlight. Birthmarks are abnormal blood vessels, very superficial up in the dermis. So you get a lot of thicker capillaries showing up right underneath the epidermis, so you see a birthmark. Cats. All right, so jaundice. Jaundice is a condition which causes yellow skin. And like it says here, it's due to a buildup of bilirubin. Bilirubin is a byproduct of your red blood cell breakdown. Daily, thousands of red blood cells are getting broken down and recycled because they go constantly through your tiny little capillaries, your blood vessels. So they get damaged and they break them down. And one of the breakdown parts is called bilirubin. Bilirubin is taken right back through the liver, and the liver then uses it to make bile. Bile is kind of a soapy substance, which helps us break up fats. But we'll learn about that in digestion. If your liver is hurt, like a liver problem, you got hepatitis, the liver's not breaking down bilirubin, it gives you this yellowish buildup of bilirubin in the skin, so you appear yellowish or jaundiced, like the old man in the Wikipedia picture there, or the baby here in the little baby picture. Here's a diagram between normal and jaundiced people. So, website there pretty much says it all. Accessory skin structures. Accessories to the skin, the hair, muscles, glands, and nails. Hair, again, is produced by the epidermis, the squamous epithelial tissue. So epithelial tissue makes hair. Epithelial tissue makes glands. Epithelial tissue creates the nails. Muscles, of course, make up the muscles. So the hair root and bulb, they fall deep into the dermis. So it's part of the epithelium which delves deep in the dermis. And basically all it is it's that stratum basale putting on little flat squamous epithelial cells, as you can see right here. And it's the keratinization zone where they're putting keratin protein, filling those cells up with keratin protein. They're getting laid on with little shingles, like our stratified squamous epithelium does to us. That stratum corneum on top protects us. The melanocytes, site means cell, their cells producing melanin, and that gives the pigment the color of our hair. As you get older, of course, you stop producing melanin and your hair gets silvery gray. So the hair shaft, like we're going to do in our lab, or you've probably already seen in the lab by the time you view this, it's the little tiny, you can see the squamous epithelium laid over top like little shingles. So it's keratinized epithelial cells. Epithelial, epi upon, so the outer layer, and they're the stratified squamous epithelial. Again, I like this diagram because it shows how your little pink layer up there, the pink and yellow is like the stratum corneum, but the pink is your epithelial tissue, and it falls deep into the dermis here, the light, almost whitish, purplish pink. It comes deep in the dermis, forming the hair follicle. And then, of course, it also forms the sebaceous gland. Epithelial tissue creates the glands. And again, here's your little erector pili muscle, which every single hair follicle has a little tiny muscle like that. When you flex it, it looks like a little goosebump because that's what we call them, goosebumps, and it pulls the hair up to keep the wind from pulling the heat off of us. So if I got scratched way down here, deep under the epidermis, in the dermis, the epidermis still down the hair follicle would help regenerate that epidermis on top of the skin so we would not have a scar. So hair is just like stratum corneum. It's very keratinized, all those epithelial cells, and they're added again from the bottom. The hair grows from the bottom. That's why you shave. Guess what? More pops up out of their skin. It's like, it happens. By the way, after you die, your hair doesn't continue to grow. What happens is your skin shrinks from dehydration, so the hair already on the follicle is now protruding past the skin due to shrinkage. So the hair doesn't continue to grow, your skin shrinks. Just a little trivia thing there. Okay, the hair follicle rests on a dermal papilla. Again, the little blood vessel under the dermal papilla feeds stuff above it, in this case, the hair. And little FYI, fun thing to know, your hair can grow for 2 to 5 years. Mine doesn't grow that long. But then you shed it over the telogen period, your hair falls out. Some of you girls, like my wife, can pull out, seems like 1,000 hair strands a day out of the shower. It's like, dude, but it keeps growing. So you're lucky, I guess. My haircuts are cheap. Here's the erector pili muscle under the microscope slide right here. Here it is in the diagram. I like this nice little diagram. That little tiny muscle, itsy bitsy tiny muscle, but when it flexes, you can see the bump under the skin. And its main job is to pull the hair up when you get cold, and the hair then helps block the wind from taking the heat away from your body. It's also nice for the flight or fight response. That little kitten gets scared, and it throws its little hairs up. It looks kind of scary. Okay, it looks just hilarious, but it can look scary. And again, the goosebumps help pull the little hairs up, and they block the wind from taking so much heat away from your body. Sebaceous glands, these things on the side of the hair follicle, produce sebum, mostly lipid, but some cells, some squamous epithelial slough off in there, just like yours does on top. And that helps moisturize not only the hair itself, but also the skin surface and keeps us from drying out. That's why you wash your hands so much. You get very dry because you washed all the sebum off. Now your upper squamous epithelium is flat. It's flat, yeah, it's very dry, and it gets very rough, starts flaking off. The sebum can be used by bacteria. They can eat some of the cells in there, but the oils itself kind of inhibit a lot of bacteria growth, and it helps prevent the drying of skin. In the background, you have a sebum. This guy by the sea, he's a bum, and bums don't really have time to shower, so they get really greasy. So they got greasy hair. Sebum, greasy hair. Get it? Okay. Another diagram here showing the stratum corneum up top, flat layers keratinized. These strata, you don't need to know, college you will, but the stratum germinate, anyway, we call it the stratum basale, now the base layer, it's the one constantly reproducing, and it dips way down to make your hair follicle. All right, sweat glands, we talked about these in class. Apocrine make you smell like an ape because they kick in during puberty, and they dump straight into the hair follicle. That's why I like saying apocrine, because apes are hairy, apes are stinky, I think. Never really spent a lot of time with one. So the apocrine sweat glands dump in at puberty. They contain organic compounds which the bacteria feed upon and stink. They open into the hair follicle, so apocrine into the hair follicle. Merocrine sweat glands, they're with you all the time, from childbirth on up to now. They put a lot of salt water out. They dump straight onto the skin surface through the little pore, through that sweat duct right there that goes down to the merocrine sweat gland. And since they're mostly water and salts, little kids don't really stink like your volleyball knee pads. They smell more like just a little wet kid. Not wet dog, wet kid. And here's some practice for you. We did this in class. 8 shows up okay in my computer screen. I don't know how it'll show up on yours. It's very faint back there. It's the erector pili. And number 9 is the merocrine sweat gland. Again, more practice. Diagrams like you see on the test. The hair shaft is important. 3, the hair follicle bulb. The erector pili muscle. I don't have the sebaceous gland labeled here, but here it is down below. You have your blood vessels, your capillaries. All right, ceruminous glands are basically modified sebum. They're in the ear somehow. Your ear is designed to read the DNA that produces cerumen, not just sebum. And this is cool because cerumen is thicker. It's more waxy. It is insecticidal. Insecticidal means it kills insects. They try to go in there, and if an insect were to try to eat through your ear to get to your brain, it would die. It protects the eardrum, and any objects that might get lodged in there, that earwax is being produced. You just kind of jiggle the outer auricle there, the outer ear, pull that out, and let gravity pull it down, and that eventually falls out if you get a pebble lodged in there from your buddy throwing it at you. Not that's ever happened before. Oh yeah, Shrek. He makes candle wax out of his. You could do that too. It might gross your parents out, but yeah, it's feasible. Mammary glands are nothing more than modified sweat glands. So it's a sweat gland modified with surrounded by a lot of lobes of fat, and they are nutritious for that species baby. We don't feed human babies cow's milk because the babies would have a lot of diarrhea. They can't digest the proteins in cow's milk. We like making cheese out of cow's milk. Tastes good. Some of you like drinking cow's milk. More power to you. I don't, but I like ice cream. Little kittens like cow's milk. It tastes good to them, or maybe there's like the little teats hanging down to play with. Who knows? So yes, mammary glands is why we're called mammals. We have mammary glands. Nails. They're layers of stratum corneum put on very thick at the nail matrix of the nail body and pushed out onto the surface of our fingers. And they're nice because back in the day we had Brillo pads. We had to scrape and clean our pots and pans and stuff with our nails. And because they kept growing, we keep on scratching away and wear them down. So the nail body itself is keratin protein. It's a visible part. The root is covered by the skin. The little white part underneath is the lunula, and the free edge is the end. Bing, bing. The eponychium. Epo means upon, niki means nail. So your eponychium and your cuticle protrude out over the nail here. Right now we're going to say that eponychium and cuticle are the same. It's a fine line, a gray, hard to divide them, so it's called eponychium. Okay, the stratum corneum extending over the nail body. The lunula is our little moon, literally means little moon. The bed is the point of attachment underneath there, and the matrix is a thicker proximal bed, which you can see, what you can't see actually. It's under the skin. You can see the bed under the skin, which is, of course, that part of the lunula, the nail matrix, which you can see. Okay, and it's the same thing all over again, but this goes into more detail, like hyponychium, hypo under nail. They stick bamboo shoots there for Chinese water torture. No, Chinese torture, that's not good. You don't do that. Painful. And the diagrams we have, we already labeled these in class. Again, the nail body, the lunula, eponychium, nail root. So yes, these diagrams, you know you've seen them on the quiz once, you'll see them on the test again. Burns. First degree burn is the upper layer of the integument. That's through epidermis. And heals completely due to regeneration of the stratum basale. Sunburn is laid below, or maybe you've touched it up against the barbecue pit real fast or got under too hot of water. Second degree burns, boiling water, deep sunburn, flames, contact with hot, greasy liquids, who knows what. But it burns down to the dermis and can shed, like you see that epidermis shedding right off there, peeling off. Ouch, pain. But remember, you got hair follicles all across there that go down with the epidermis. So the epidermis will regenerate from the hair follicles and there will be no scarring, hopefully. Third degree burn, there will be scarring. It burns down to the subcutaneous layer. It takes out the nerves. It takes out the hair follicles. So there's nerve damage. You can touch that guy right there. It's probably killing him all around the outside edge. But if you touch the middle of his leg, he probably doesn't feel it. Those nerves have been burnt bad. The hair loss is permanent. Hair follicle's gone. Now it'll be a dense connective tissue, a scar forming there. Cyanosis, redness, and paleness. What are the causes? Well, we already talked about cyanosis. The blood, you get very low oxygenated blood. You look bluish. Your lips appear blue. Redness can be anger, can be heat. The superficial blood vessels open up. And paleness is low blood pressure. The blood just drops from the superficial area and you look very light and white. All right, we'll stop here at about 14.5 minutes. We'll talk about this slide to start off section part 3. Thank you, we are done.